Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Cole.
And in studio with us we have Tayden. And Tayden, if somebody needed to get in contact with us, what would they need to do?
For math homework help, call in Bakersfield 636-4357. And everywhere else, 1-866-636-6284. Our email is dothemath@kern.org, and we're online at dothemathonline.net. And on social media, Facebook, Instagram, Twitter, and YouTube.
All right, nicely done. So Tayden, what grade are you in and what school do you attend?
I'm in 6th grade and I go to Buena Vista Elementary.
So you're a bulldog?
Yeah.
All right. Have you been a bulldog for a long time?
Yeah, this is my 8th year.
Whoa, since TK.
Yeah.
So this is your 8th year.
Yeah.
And how old are you, 12?
I'm turning 12 soon.
So you're not even 12 if you spent 8 of your years at Buena Vista.
Well, this is my 8th year.
This is your 8th year.
Yeah.
All right. Well, we'll just say 8 of your 12 years when you turn 12 will be completed then.
Yeah.
Do you think you're going to miss anything next year when you go to a new school finally?
Just the school itself, the campus.
Yeah, well, I mean, you're pretty used to it.
Yeah,
You know where
and-
everything is. And
Yeah.
next year, do you know where you're going to junior high yet?
I think Warren.
Okay.
Warren Junior High.
So you'll have a new campus to get used to, new instructors, new friends, a whole lot of new stuff
Yeah.
coming up, right? You nervous about that at all?
I mean, I know that there'll be a lot more people there because many different schools are gonna all the students from many different schools
Right.
go into one school.
Well, that'll be a lot of fun, right?
Yeah.
You'll be able to get a lot more friends.
Yeah.
Right? You meet newer friends and things like that. All right, so one of the things that you're working on in school right now is ratios and proportions, correct?
Yeah.
All right, why don't you head on over to the board. You and Cole quickly are going to, within a minute, just kind of talk to us a little bit about what you know about ratios and proportions, all right? Take it away.
Okay. So a ratio is multiple numbers that you're just comparing them. In a ratio 1 to 2, you can write them. There's 3 different ways of writing a ratio. One way is with the colon, like this. You could also do 1 to 2 in a word form. And the third way is fraction form, 1/2. So that's read 1 to 2 still. So this, you're comparing the 2 numbers. So for example, if these are apples, so if they're, okay.
That's okay. I had the same problem this morning.
So if there is 2 apples and there's 2 apples for every pear there is, that means there's double the amount of apples than pears. Mm-hmm. So if there are 4 pears, there will be 8 apples because there's 2 apples for every 1 pear there is.
Interesting. So would you be able to write that as a proportion showing us kind of pears to apples with that example you just gave us?
Yeah.
Yeah, what would that might look like?
Wait, Could you repeat that?
Yeah, so you said that 1 pears to 2 apples. How might I write, you also said that 4 pears is 8 apples. How might I write that as a proportion to show that relationship?
So you could 1 to 2. You could also make that 4 to 8 because they equal. They're basically the same thing, the same ratio, because you just multiply the numbers by 4.
Very good, so the proportional.
Yeah.
Yeah, awesome, thank you.
All right, so I'm glad that you were able to show everybody the 3 different ways to write ratios. And it sounds as though you've got a pretty good understanding of what a ratio is when you talked about comparing one thing to another. All right, nicely done. We'll get you some more of those problems with ratios and proportions in just a little bit. Time now for today's Math in the News. All right, well, we are celebrating our 20th year on Do the Math. We've had a lot of fun during the past 20 years, and we have one of our originals here. Cheryl, how are you today?
I'm wonderful, and you?
I'm wonderful myself, still kicking at it here. But you fortunate enough to have been retired now. How long have you been retired?
3 years.
3 years. You're loving it, aren't you?
I love teaching. I do.
So you were part of Do the Math at the very beginning. Do you remember what happened or how you heard about it or how you got involved with the program?
I think my principal came to me and asked if I would represent our school in the Do the Math.
And did they tell you anything about it, or did they just say, hey, we need you to go represent the school and good luck with whatever's going to happen?
They told me a little, but most of it I found by working here.
Okay. And what are your fondest memories of when you were here with Do the Math?
This is going to show how much of a math nerd I am.
We all are here, so.
I loved doing algebra. It was my funnest thing, teaching and
I'm Michael.
being it on the show.
Did you have a good day at school today?
Wonderful day.
As I'm sure your students did as well.
I hope so.
Lots of fun doing math.
No nickels, I still at 1 cent, 2 dimes, 20 plus 1 is 21. 2 pennies, 2 cents, no nickels, I'm still at 2 cents. 1 dime.
You came on, you asked me if I knew.
There we go. So there you are once again with Barb.
Different schools.
And I don't know who that guy was right there, but that guy looked a little off. Anyway, so you loved algebra. Do you think, I mean, did you teach that for a long time, or did you move into different areas of math as you were working?
Mainly algebra. I taught a few classes of pre-algebra, maybe mainly algebra.
Okay. And I do remember, they brought this up, that I had referred to you as the stickler.
I know I was.
So the stickler. Do you remember why? Because I can kind of remember, but do you remember why I referred to you as the stickler?
Particular on how I wanted things done, especially in my class. So probably that was why.
Right. I mean, there are certain ways you want things done, and you need to present things. And so let's take a look at this right now.
Good afternoon, students and parents. If you'd like to call us for help, we'll be glad to help you. Parents, if you're helping your child and want to call us, we'll help you too. For those of you who've done T-tables, this is almost a version of that, but we have 3 coins. Okay?
Do you remember this
so
episode?
it says he has pennies, nickels, and dimes, or dimes, because I'm a stickler and
Pennies, nickels, and dimes.
and dimes.
There you go, stickler, right?
You look so young up there.
I'm thinking I'm still looking pretty good.
Yeah, you are.
All right. We all looked younger back then, 20 years ago, right? So you had many great years. Were you always at Actus, or were you at different school sites?
I taught for the superintendent schools for 3 years. Then I was at Actus for 19, and then I spent my remaining years at Ward.
Okay. And did you find a concept that students, they were readily, like they could grasp onto that and they kind of understood it pretty quick? Was there anything in the past that you're like, yeah, you know what, when I taught this lesson or this concept, kids were able to get that pretty quick and easily?
Problem solving was probably my favorite. And then I would do an example, and the class would work with me, and then I'd have a student do an example.
Okay.
So that was one of my best. And then I loved proportions, working on those with students so they could see how it applied to real life.
And that, I think, is the biggest thing right there. And that's something I think that most of the students will be able to take away with, from these different math courses is, how am I going to be able to use this once I'm out of this classroom for 50 minutes and move on to something, that's more important, let's say, to them. Well, you know what? We certainly do appreciate you coming in. And do you remember how long you were here? Because I know you were here with me at the beginning.
I think 4 years.
4 years. So that's,
Maybe more, because I started, it was definitely more because I started at Active.
okay.
So
Well,
we're
that's
talking more like 20 years.
Well, there you go. So see, you can remember those things based on how many years you were at a different place, not how many years I was at this place. Well, Cheryl, we do appreciate everything you've done for us in the past at Do the Math, especially to help get it going and to help, because if it didn't get going the right way at the beginning, we would not be here 20 years later. And that is in a great deal thanks to you and everybody else at the beginning of the program. So
Thank you.
thank you once again for coming in and for sharing your skills with Do the Math. And that is today's Math in the News. 636-4357 is the phone number. We do have phone tutors available until 5:30, as we do most Tuesdays and Wednesdays throughout the regular school year. As Tayden reminded you, we are also online at dothemathonline.net. And the reason I bring that up is because a lot of students hear about the program and they go, well, I know you guys are on cable, but for some reason we don't have cable or something, or you're out and about, and you can always get us online at dothemathonline.net. In studio, we have Tayden with us, and Tayden is working on ratios and proportions. Right now, let's take a look at one of the math problems that Tayden is working on. So Tayden, the skull accounts for 15% of the weight of a beast's bones. So the skull is 15%.
Yes.
So if you want to go to the board, I don't know if you want to write anything down now. So you might want to write skull 15% somewhere.
So the skull equals 15%.
15%. And the beast's bones, so the bones account for 21% of the total weight. So the bones are 21% of the total weight. It says, what is the total weight when the skull is 570 pounds? So the skull is 570 pounds.
Okay.
So you might want to write skull equals 570 pounds somewhere also. You can put it right there next to it. So we want to know the total weight of this beast when the skull was 15% of the total and the bones are 21% of the total weight. Kind of makes sense? So it's going to be a couple of steps in here. So how do you think you want to approach it? And Cole is here to help you out with it.
Okay. So it's asking what the total weight of the beast when the skull weighs 570 pounds, right?
Yes.
So the bones don't really have anything to do with it. The question is just asking about the skull. So we want to figure out how much the total weight is. So the total weight of the beast
Can you walk me through kind of what you're thinking as you're writing
So
down?
I'm gonna assign this to a variable.
Okay.
So we'll use x
And can I ask why you assign that to a variable, just out of curiosity?
because x is an unknown number. We don't know how, we don't know the weight of the beast. So we'll use x to take the place of the unknown number.
Oh, fantastic. So you just assigned something you didn't know with x. Okay.
Yes.
I follow. Thank you.
Okay. So, and then we know it's 15%. So I'm gonna just turn this all into a fraction, like just cross multiply.
Okay.
So we can do 570 and then x and then 15 for 100 because 15% is out of 100.
Okay.
Now these are equal because 570 is 15%, right?
Mm-hmm.
So we don't know what x is, but you can cross multiply. Wait, how do you just? Oh, okay. So if you cross multiply these two numbers, then divide it by 15, you can get you can get x. So basically, that's like just doing 15x equals 100.
And can I stop you for a second? How do we know we can do that? I'm really curious. How do we know we can just cross multiply like that?
So if you these are the basically these are the same, they're equal, and what you do to one side, if you do the same thing to both sides of the equation, then it'll equal they'll still equal the same things. So
So you're correct so far.
No, you're correct.
Right.
I'm sorry. I was just curious what. Yeah.
And
your
what I want to
thoughts
do for you is save you a little bit of time here. So when you do that and you get 570 times 100, you're just
Yeah.
going to add 2 zeros, so you're going to have 57,000,
yeah.
right? Divided by 15. That is going to come out to be x is equal to 3,800. So if you want to just put underneath that, x is equal to 3,800. And that's where you're at now.
Yes.
So now you'll continue with the problem.
Okay. So
So take a look at the information that you've got. If you need to move the screen up again, or we can always do that a little bit.
so the school.
So talk to Cole. What's going through your mind?
Okay.
What do you think you have to do, or what do you think is missing?
So are we looking for 21% of this number? Or is that?
So let's go back to the question real quick. Let's
Yeah,
review real
so-
quick. What is it asking us to find?
It's just it's asking for the total weight of the beast if the skull weighs 570.
Yeah. So
Okay.
I'm curious. I have 3,800, but
Okay.
what?
So so these equal 6. So 15 times this will equal this.
Okay.
Okay. So doesn't that mean this is the total weight?
And just 3,800?
Yeah.
Is it?
Oh. Do we add the skull, right?
So what would be my units? 3,800 what?
Oh, just pounds.
Here we go.
That's it?
Yeah. Can we write that back as a proportion to show us all what that would look like? So can you plug it back into your x up here?
Okay. So x equals 3,800 pounds. So the total weight of the beast is 3,800 pounds.
Okay.
Yeah. So what are you asking me to do?
Yep.
Now, yeah, because the skull
Right.
is what you've got,
Yeah.
right? But the bones are 21% of the total weight. right? So you're going to do something else with that 3,800,
Okay.
right? So you're going to set up another proportion, right? Because the 3,800 is to the total, and 21% out of 100 is the 21%. Does that make sense?
Mm-hmm.
So you already did something with the 15% over 100, right? You did 15 over 100.
Mm-hmm.
You still need to do something with that 21, so you're going to set up a 21 over 100. So that's going to be 21%.
Yeah.
And you're going to compare that to what now? What's your new number you've got?
This.
There you go. So where do you
So-
think that's going to go? Is that part or the total?
Total.
Well, that's the total for the
For the, with the skull.
the bones, right?
Yeah.
You want to know the whole weight of the whole beast now. So do you know the weight of the whole beast?
So
Not yet, right?
basically, just finding 21% of this number and then adding it.
I believe we just found that though.
Right. So what you're going to do is you're going to set up. So you're going to make that ratio equal to. So 21 over 100
Okay.
is going to be equal to 3,800 over the total t. Let's say. Okay. So what would you do now?
Do the same thing, cross multiply, and then divide.
Okay. So when you
So-
cross multiply, what will you get?
Oh. 380,000
Okay. And what are you going to do with that number now?
divided by 21.
There you go.
Okay.
And you don't have to do that because I'll do it on the calculator here for you, all right? So what I want you to do is write it though. So
Like-
380,000 divided by 21, and then put an equal sign, and then underneath it we'll put what this is, because otherwise it's going to take you a while to actually divide it. So it is 18,095. And it's 18,095 what?
Pounds.
Pounds. So now what I want you to do is, you and Cole, I want you to kind of go back to the beginning and take a look and see if all of this makes sense and if the answer seems reasonable now.
Okay.
So let's think maybe back to what we were asked to begin with. You want to do that real quick? Revisit the question? Make sure that we're answering the right one. So it says the skull accounts for 15% of the weight of a beast. A beast bone accounts for 21% of its total weight. What is the total weight of a beast whose skull weighs 570 pounds?
Okay.
So how can we kind of justify our answer based on the question that we were asked? What are we thinking?
So I mean,
And it's a difficult problem, Grant. I mean,
so what I mean, I don't understand like what does like the question is asking what the weight of the beast if the skull is 570 pounds, right? So 570, so that's 15% of what? The total weight of the beast?
of the beast's bones.
Oh,
So it's 15% of the beast's bones, is what it should say, beast's bones. Right? The bones are 21% of the whole weight.
Oh, so I
Does that make sense
misunderstood
now?
the question. Yeah.
Right, so the bones are 21% of the total weight. And out of the bones, the skull is 15% of it.
Of the bones.
Right,
Oh, okay.
so the first one that we saw really was the weight of the bones.
So the
Right,
skull is
yeah.
50. So, okay, so 570 is 15% of the bones, and out of that, that's the total weight of the beast.
Yeah.
Okay. So.
Right, so what we need to do is just add the word bones in there so that,
Yeah.
Okay. Okay. So, what were you asking me before that?
So if we know that 15%, the skull is 15% of the beast bones, how much do the bones weigh?
Oh, okay.
So how much do the bones weigh if 15% is the skull?
The bones.
yeah, that's your 3,800.
Okay. So this is the total weight of the beast, and this.
So what you've got written at the bottom,
Okay.
21 over 100 equals 3,800 T, right, over T? So you're saying that 3,800, right,
Yes.
is the 21% of the whole thing, because 21 over 100, you've got part over the whole.
Okay.
So the 3,800 is the part
So
over the whole, which is the bottom number.
3,800 is the weight of the bones.
Right.
Yeah.
And then you use that to get the total weight. So hopefully, after talking through that, it makes a little more sense now?
Yeah.
Okay. Well, good, because we've got a young man on the phone. Nathan, how are you today? Nathan, you're there?
Yes, I am.
Okay, so leave that problem up on the board, because Nathan, you're a 6th grade student from Cybert, correct?
Yes.
And I believe you're working on the same problem, correct?
Yes.
And were you watching it being done on air while you were waiting online?
Yes, I was.
Okay, good. So what questions do you have? Do you understand what Tatum was doing with Cole?
Yes, I do.
Oh, good. So what I want you to do, just so I can make sure you understand what you're doing, Nathan, so Cole, if you can kind of highlight that 21 over 100 is 3,800 over T. So Nathan, what's going on there? Are you able to kind of explain to Cole what's going on right there, how that part came about?
And you can, line a few seconds because it's starting to come through for me on my side. What you're doing is, so you're getting what the 21% would be as a fraction with the 3,800. And then what you're doing is pretty much just like, I think, cross-multiplying it, I think, hopefully.
Okay, so I'm going to just make sure that I'm following your thinking correctly. So you're saying that I've set it up and I'm going to cross multiply like this?
Yes.
Okay. And then what did you do after that?
So you times the 3,800 by 100, which gave you 380,000. Then you divided it by 21, which would be the number of the total weight, or yeah, the percent for the weight. And then that got you guys 18,095.
Good. Okay, so you did understand with that cross multiplying and dividing, correct?
Yes.
And you see, so your final answer was the 18,095 pounds, correct?
Yes.
All right, good. That's what I wanted to make sure, that even though Tatum was going through it, and we had a little terminology in there we need to throw in there with the bones instead of the whole thing, that you did understand what you were doing. So Nathan, for calling in today and making sure that you understood what that problem was, you've got yourself a meal, courtesy of our friends at the Broken Yoke Cafe, so congratulations on that. All right, so Tatum, do you think after hearing what he said, it still makes a little sense to what you were doing?
Yeah, so I think it's just because I misunderstood the question.
Right, and I think that was the
So,
problem when
yeah.
instead of like the beast bones, I think that's kind of what threw us off there a little bit.
Yeah.
But you did a nice little job on that, so we're going to have some more of those problems for you in a little bit. But we'll be back with more right after this.
Octuplets, the high jump, and multiplication. What do they all have in common? Today's word is composite as we explore the language of mathematics. Where were you in 2016? Because I'm sure you remember that moment where 8 identical siblings took the floor of Rio de Janeiro's Olympic Stadium and simultaneously cleared the world record high jump. You don't remember that? You need the evidence, right? Well, we all remember this moment. Okay, so perhaps you're wondering, how is this possible? This didn't exactly happen the way I described it. What you're looking at is a composite photo, sequenced by one photographer who took 8 consecutive rapid-fire images of this attempt at the high jump. He then pieced elements of those together to create this one image. So this is called a composite photo because multiple pieces came together to make this. So that brings us to our term today, composite. Composite comes from the Latin of componere, meaning with and to place, or to put it together with different elements. So we have different pieces of this term that make other words that we're familiar with in our language. A composer is somebody who makes music for others to perform. You might call that piece a composition, and you've probably also heard that term composition as far as a notebook that you might be writing in for an essay or other notes. If you're working with electronics or you're putting pieces together, you have different components that you're putting together. But when we talk about math, we see this term in regards to numbers, specifically composite numbers. A composite number is a number which can be created by multiplying 2 smaller positive integers. So what do we think of when we think of composite numbers, or what it makes a number composite? Well, here's some examples we can consider. 9 is a composite number because beyond simply itself and 1, you can use other numbers to multiply to get to that product of 9. 3 times 3. Now, some other composite numbers are big because they have multiple ways of getting there. With 32, you can do 2 times 16, 4 times 8. You can even break it down into smaller pieces. 4 times 4 times 2. Because you have all of these other ways of multiplying to get to 32 beyond simply 1 times itself, 32 is also a composite number. There are some numbers, though, that are not composites. For example, 17. The only way to multiply to get to 17 with 2 whole positive integers is 1 times 17. Because it's not composite, we have another term for that, prime. And in another video, you'll have a chance to explore the idea of prime numbers a little bit more deeply. But now you know how to put pieces together and make your own composite number. Join us next time as we explore the language of mathematics.
All right, thanks for that, Devin. Always nice to learn some new language as far as it's relating to mathematics. Composite, one of the many words that we have featured on the language of mathematics. We do have phone tutors available until 5:30 this afternoon. Tayden, a 6th grade student from Buena Vista, is in the studio. And right now we've got Steve, well, you're a music instructor, but you're a little bit more than that with the Panama Buena Vista School District also. You want to tell us a little bit more about that?
Sure. I'm the Visual and Performing Arts Administrator for our district, which means that I oversee all of the visual and performing arts for the district, which is mainly getting support for our teachers, making sure they have the tools that they need in order to continue our successful program.
All right, great. Well, you've got Tayden over there, a student from your district, so you guys can take it away.
Right on. Hi, Tatum. Today we're going to talk about tempo. Have you ever heard of the word tempo?
Yes.
And do you know what it means, just roughly?
It's like the speed of the beats.
Yeah, absolutely. It's the speed of the music. And then you kind of got ahead for my next question about, have you ever heard about what a beat is?
Yeah, it's like the steady, I don't know how to explain.
You're doing
just
it,
yeah. It's like steady. It doesn't change, and it just keeps going.
Right. Yeah.
Yeah.
We call it the pulse of the music.
Yeah.
So you could have a slow pulse, or you could have a fast pulse, and so really the pulse really dictates the tempo. Okay, so if you look up here on the board, and I know your teacher, so I know that you know this stuff. This is just a quick little review. These are quarter notes. These are eighth notes. A lot of times we use ta, 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 ta for the quarters, and that's going to be our beat. That's going to be our pulse, our basic pulse. These are eighth notes. They are exactly twice as fast as your quarter notes. Right? You remember this?
Yeah.
Let's clap this together. We'll do it 2 times through. Okay? So that means we're going to do it twice. Ready?
Okay.
And perfect. Okay? So we just did this twice, or 8 total, and that is our beat. So here we have eighth notes, and we already said by saying T, 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 we're going to go twice as fast as the beat. Let's do that twice through, okay? Ready, and... Cool, perfect. So these twice as fast as these. So if you say you're in the orchestra, right? You play strings?
Yeah.
Okay, so if your strings teacher sends you some music home, and it might look like this. Okay, and there's some really kind of strange words. I know Mr. Kushine told us a little earlier that we learned some new vocabulary in math. We're going to learn some new vocabulary again. This is actually Italian. Okay, and so our first word that we see here is pronounced adagio. And up here on the board, adagio means slow and stately. Literally, English, from Italian to English, it means at ease. And then our next one, our next exercise, it said allegro. And that means fast, quickly, and bright. And then this last word, in English, it looks like what?
Grave.
Grave, it does. And there's kind of something to that. But in Italian, we would call it grave, all right? And that means slow and solemn, kind of like you were going to the grave, right?
Yeah.
So up here with my definitions, I also have that adagio is 55 to 65 BPM. Any idea what BPM might mean?
Beats per minute. I've heard it before, I think.
You are my A student right now. You're killing it all. Yes, it absolutely means beats per minute. So if I were playing something in the style of adagio, I would be playing with the beats being somewhere between 55 and 65. And so for allegro, something that's fast, quick, and bright, it's between 120 and 160 beats per minute. So considerably faster, right? And then lastly, our slow and solemn grave is only at about 20 to 40 beats per minute. Okay, so our music teacher gave us that homework, and we finally figured out what adagio and allegro and grave mean, and so now we got to find out how fast that is. That's when we go to a metronome. This is what most people think of when they hear the word metronome. Do you happen to have a metronome at your house?
I don't think so.
Don't think so. Yeah, these are becoming kind of uncommon. I'm not sure. I'm sure you can get on the internet and buy them, but they're really just kind of being outdated. Now today we have things that kind of look like this. And see, it can figure out, if you see it's already set to 120 beats per minute. I don't know if you guys can hear that at home or not, but okay. So yeah, and here's the cool thing about it is we can set it very slowly, and we can also make it go really, really fast. Okay, but not, do you have one of these at home too?
I don't know.
You know, I probably not, because why would you? All right, but something I bet that you do have at home. You have one of these at home?
Yeah.
Cool. Now, what do you notice about? First of all, what is that?
A clock.
It's a clock. Cool. What do you notice about it?
It's, well, the second hand or is like slowly like moving suddenly.
Cool, exactly. And you can see this one jerks a little bit, and I don't know, and I really don't think we could be able to. We actually can hear it now. So you already told me, because you're like super student, you already told me what BPM means, beats per minute. How many, so this tempo that we're hearing on the clock, how fast do you think that is?
60 BPM?
You are exactly correct. That is 60 beats per minute. So if your music teacher gave you something to play and it had one of those Italian words on top of it, but you didn't really know how fast it is, which one of these words would be what you could get directly from the clock?
Adagio?
Adagio, exactly, because that's between 55 and 65. So boom, that's how you get Adagio. Now, you already told me that you had some other knowledge, and by using the math, I'm going to challenge you. How could we figure out what Allegro is? Because we already know that our clock is giving us 60.
Well, it's 120 to 160 BPM.
Cool.
So if this is 60 BPM, then you want to be doing like around two beats every time it goes once, it ticks once.
You are exactly correct. So if we set our metronome or our watch, because I think you can probably hear this a little better, what could you use up here to get 120?
TT.
Yeah, TT, because they go exactly twice as fast. So if this is Adagio, do it with me. Going a little bit too fast. Now you know how fast 120 is. So now, just by using your clock at home, you know Adagio, you know Allegro. So the tough one, how do you figure out grave?
Maybe do around one beat every 2 ticks.
You're exactly right, once again. So we know what 60 is because we all have a clock at home. So 30 beats per minute would be this. Is that pretty slow?
Yeah.
Is it pretty solemn?
Yeah.
Yeah, exactly right. So yeah, you figured it out. So now with just a clock that everybody has at home, you figured out 3 different tempos, and you can practice at home just by having a clock. You did an amazing job. You got everything perfectly correct.
Thank you.
Nicely done, Steve, and Tayden as well. Wonderfully done, and even learned a little bit of Italian today. So Steve, thanks for coming in, and that great lesson incorporating math, music, and language. 636-4357 is the phone number. We do have phone tutors available, and last week we started a little feature on some dolphins and how they're helping to save lives. Here's part 2.
This week, Lab TV travels to the Navy's Marine Mammal Program in San Diego, California, to explore the dolphin's amazing ability to locate objects using sound.
Well, one of the things that we like to do is find mines or underwater objects, and mankind living on land is not very good at finding things underwater. Now, a dolphin makes its living underwater and has been doing it for a very long time. So tasks that we find difficult to do, they find easy to do. Therefore, we use them for that purpose of finding underwater objects. The number one thing that allows them to perform this job is echolocation. And echolocation is really locating objects by the echoes that they produce when sound hits them. Now, dolphins produce sound. We call them echolocation clicks. The clicks because that's what they sound like. It's kind of like a snapping finger. And they'll produce these over and over while they're swimming through the ocean. We know a lot more about what the animals are doing now by monitoring the strategies of the animals. But how the animals do it is also important. What we have here on this screen is a CAT scan of a bottlenose dolphin. And the red material that you're seeing is actually the air inside the skull, because air is reflective to sound underwater. The dolphin uses this structure of air to actually help get sound directed towards these yellow structures, which are the ear bones of the dolphin. Now, unlike humans, the ear bones are actually separated from the skull. And if you notice the little air around them on the inside, that helps shield one ear from the other ear. And that's one of the ways that they are able to tell which direction a sound is coming from underwater. Now, what I have in my lab is an instrument that we built called the BMT, or the Biosonar Monitoring Tool. Now, this looks kind of crummy at this point, but has been through a lot of use. I want to explain quickly what it is to you. The dolphin carries this instrument with a bite plate. It actually accepts it with its mouth. As it's moving through the water, an underwater microphone, or a hydrophone, collects the echolocation clicks as the animal's producing them. In the front of the instrument are two receivers, which are separated in space to the same distance as the separation of the ears in the animal. And these receive the echoes off of the targets that the animal has insonified. This instrument also has all sorts of sensors inside of it, so we know how fast the dolphin's swimming, its position in 3 dimensions, and the depth that it's at. And we can take all of this information and we can put it into a virtual reality world to try and get a better understanding of what the dolphin is doing. Now, what I have behind me is a virtual reality representation of a dolphin doing a search for a mine. You'll notice that the dolphin is carrying the BMT, and this is exactly what it would look like when we were doing this underwater. The green object in the back is the mine that the animal is looking for. The yellow that you see on the landscape, that is the sound being projected by the animal, is kind of like a spotlight. Now, what you just heard were echolocation clicks, repeated snapping sounds. As he gets closer to the bottom, you will hear the sound from the bottom come back to him. And when he gets close to the target, you will actually hear the target as he approaches it. Now you are hearing the echo of the mine and the land around the mine. Now, at this point, the animal has got a really good idea that this is what he's looking for, but he's going to swim by it and check it out anyway. And when he's found it, he whistles to say, "I found it." Now, the sounds you hear now are the animal's victory call. Oftentimes, the animals, when they have completed the task that they've been asked to do, are happy with the fact that they've done well and will reward themselves with their own victory call.
To find out more about echolocation, check out labtvonline.org.
Fascinating with the dolphins, and glad that we were able to see both parts of that last week and today. We do have phone tutors available until 5:30 this afternoon. Cole is in studio with us, and Cole, it's been a while since you've been here, but you are here now. You are an employee full-time of the Kern County Superintendent of Schools office.
That is correct.
What is your role with the county office?
So I'm a math coordinator for the county office. And I go, basically my job is to go out and I support teachers and administrators, providing demo lessons in classrooms and helping teachers plan and focus on best practice for mathematics.
Good, okay, because I'm sure that a lot of kids, well, you said you're the math coordinator for the county, but what do you do? Just sit around and do math problems all day? But
pretty much.
So but you're doing more than that in a way that will help all of the students by going to the different schools and working with the instructors and things like that.
Absolutely.
All right. Well, in studio we have Tayden, a 6th grade student from Buena Vista, and here's another one of the problems that Tayden needs to work on, so let's take a look at it together. Barry Casterfield earned 45 points for 30 games. So you can put up any information you think you might need. So we have 45 points for 30 games. So do you think you'll need that at all?
Yeah.
Okay. So 45 points for 30 games. And if he earned an equal amount of points for every game, how many points would he have accumulated after 5 games? So if he has 45 points for 30 games, we want to know how many he would have after 5 games.
Okay.
So after 5 games. And you can call and go at it.
All right, so what are you
Okay.
thinking?
So 45 points to play 30 games, right?
Mm-hmm.
So we need to figure out how many points you need to play 1 game.
Okay.
So divide 30 by 45.
So can I ask you a question?
Yeah.
Could we maybe think about it, how many points it would take us if we played 10 games?
Yeah.
How many would that be?
So to play 10 games, all we'd have to do is divide this by 3. And, so you can divide 45 by 3. So in that case, we can put it like this, or maybe the other way around.
So can you just talk me through it as you're writing?
Yeah,
Like, so you're
okay.
thinking, you said I could divide by 3.
Mm-hmm. So we can divide this by 3 to get 10. Then we would also have to divide 45 by 3. And that's 15. So 15 points to play 10 games.
Okay.
So from there we could go to 5 by dividing by 2. So that would be 5. Now if you divide this by 2, you would get 7.5 because 7 times 2 is 14, and just half of 1 is 1.5.
That's 0.5.
Yeah.
So you would have 7.5 points.
Yeah,
after 5 games.
7.5 works.
There you go. Nicely done. You guys have talked your way through it, worked your way through it, approached it with some simpler numbers. So 7.5 points for 5 games. Nicely done. All right.
thinking.
So let's get rid of that. And I've got a beautiful problem for you. But before we do that, since you've done some great work today, I'd like to award you with a meal courtesy of our friends at Grillin' Burgers. So congratulations on that. Always nice to have a little food after working hard. All right, you ready for the next one?
Yeah.
All right, over to the board, here we go. A 100 milliliter mixture, so maybe you put up 180 milliliters. And let's put up the ratio is 2 to 3 to 7. And underneath those, we're just going to put a letter. We're not going to write out the whole color. So under the 2 is going to be a C for crimson. Under the 3, a W for white. And under the 7, B for blue. So we want to know how many more milliliters of blue than crimson are there.
Okay. So there's 180 milliliters in total. So we want to distribute them between these groups. So if you you can add them to figure out how many different groups there are.
Okay.
So 7 plus 3 is 10, and 10 plus 2 is 12.
Okay.
So we have 12 different parts that we need to divide 180 by. So you would just do 180 divided by 12. That would get you 15. So
And so can I just back you up real quick? what, the 15 that you said that's 15 of each of those parts, just to make sure that I'm following you correctly?
Oh yeah, 15
of each of those.
milliliters. Yeah.
For each one. Okay.
So that's how many go into one of these parts. Okay. So crimson has 2, so we would have to multiply 2 times 15, which is 30. And we could also just, I'll just do this. Okay. So that 45 white.
Okay.
Then and 105 blue. Okay, so that's how many milliliters of each color there are.
Okay.
Now
should-
we need to find.
Should we go back to our question and see what we're trying to find the difference between now,
Yeah.
maybe?
So it's how many more milliliters of blue than crimson are there?
Right.
Okay, so this was blue, this was crimson. So we just subtract. And it's 75 milliliters. That's the difference.
Yeah, some great thinking there. Good job.
Okay.
Nicely done, and I'm glad that you, on your own, put the milliliters as the label unit at the end of that, simply because today we had Cheryl in studio with us, and Cheryl was part of the program when we began 20 years ago, and the reason I had lovingly called her the stickler is because she was very peculiar about particulars like that. When students are in class, if you just put 75, we don't know 75 what. Does that make sense to you?
Yeah.
Right, so 75 milliliters makes sense that you had 75 more blue than crimson. All right, nicely done, nicely done. So Tayden, can you think of an opportunity, because doing ratios like that, kind of what you did also, is you broke things down to a unit rate when you did 180 divided by 12.
Yeah.
Can you think of an instance when in real life you might need to find a unit rate, what it costs or what it is for one thing compared to a lot?
When you're shopping.
Give me a
just-
specific example.
Maybe like you want to buy like, I don't know, a bag of chips. And you see like, it's like an amount of, it's like 16 ounces, right?
Okay.
And it costs $1.99.
All right.
And then you have a different size, a bigger size of like 48 ounces, but it costs like $3.50, and you want to see like which one is the better deal.
Right, what's the better
Yeah.
deal, right? Because we want a better value for our money, right? So what you're talking about is exactly correct. So by doing these ratios and proportions and the way you and Cole were working on them today, you were breaking it down sometimes into unit rate, and you just gave it a perfect example of when you need unit rate, so that way students can see what you're doing in class actually will be applicable to when you are in the real world. All right, nicely done. Did you learn a little something today?
Yeah.
Good. Did you have fun today?
Yeah.
Good. I'm glad of that even more. Hey, you know what? We have phone tutors available until 5:30. Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.